Hi, guys. Welcome to the Advanced Refrigeration Training Podcast. I'm your host, Kevin Compass, along with my partner, Brett Wetzel. Today's episode is sponsored by Westermeyer Industries, the leaders in oil management and pressure vessels for the commercial refrigeration industry. Whether you're involved with designing a system or tasked with servicing one, Westermeyer Industries has been helping meet the needs of customers like you for the past 20 years. We offer a broad catalog of stock system components with an in-house team of engineers to assist with custom solutions as well. From oil separators and heat exchangers to system monitoring devices, Westermeyer Industries are total system specialists with industry expertise, engineering know-how, and the manufacturing muscle to help you tackle problems and deliver solutions.
So we're going to go over the last type of oil separator, the filtered oil separator. Now, Westermeyer makes one, Temp-Rite makes one. I don't think Emerson makes one, dude.
I don't think so. No, I don't think.
I've never seen one. So from Emerson. So what your two main types are Westermeyer and Temp-Rite. So these filters work by discharge gas coming through the compressor, out through the separator, and then it goes through a base plate, and then it hits this filter. Okay. And then it goes through the pleats, it aerates, oil falls down, discharge gas goes up to the condenser. The oil falls down and collects. It could either be a low pressure or high pressure. It could be the reservoir or it could be a float at the bottom. But it's using that oil separator. It's using that filter to aerate the oil and collect it and drop it out to the bottom. Generally, these are about like 95 to 98% efficient. They're the most efficient oil separators you get, and they are the most efficient under part load conditions. Whereas centrifugal oil separator is like 80 to 90% efficient, but as your load drops off, it gets less efficient. So when you're in the wintertime and the head's floated way down, it's less efficient. Now, a filtered oil separator, on the other hand, can handle those load changes much better with less load. So that is the best type of oil separator you can get. Now, the only drawback to that is it requires more maintenance. Now you have a serviceable part on this separator that needs to be checked. So there is a filter in here that needs to be checked. I like to see at least once a year, like I'm Brett said on a PM. So my one check. Now, generally, you don't want these filters to get above 13 to 15 pounds or they blow the O-ring on the bottom of the filter. So as the differential across the filter gets above like 13 to 15 pounds, it's going to cause the O-ring or the gasket on the bottom of the filter to fail. And then discharge gas is going to blow out around the bottom of the filter and not go through the filter and aerate. So that discharge gas and oil bypasses the filter and then goes out to the condenser. So this causes oil trips, low oil production out of the separator. So this is something you need to look at. Generally on a clean filter, Brett, what do you say?
Yeah, that's a good
1
assumption.
pounds differential. I mean, it depends on the load, really.
Well, that's one thing I was going to say. So to optimally check to make sure, because I mean, if you're going to have this fail, Murphy's Law, chances are you're going to fail in the summertime when your load is the highest. The higher your discharge, the higher basically your delta P is between production and your discharge, as well as the more compressors you have running. If you do have some sort of restriction, it'd be more prevalent to see it when all your compressors are actually running. So if you suspect that, that you potentially do have a block filter, Westermeyer makes a great product that actually checks the pressure between the two, actually can report back to the EMS system, where Temp-Rite, they just basically just have a differential gauge. And if the differential gauge goes up to, like you said, 13 pounds, it goes up to the red, and it's just a digital input.
I'm going to be honest with you. I've never seen one of those in Warren. So I started, we took over an account in like half one program. I started setting them up where the set control locked on for like 5 minutes because it blows and then it'll trip, it blows, and then you
Yep.
never know because it resets right away. So before the E2 can even realize that if the logging is 3 minutes before it even logs it. So I started setting it up so if it turns the digital input on, it has a 5-minute time off. Or but time on. It's locked on for 5 minutes. That way you shut off
Yeah. No, I
before the
agree.
log catches it. So, but I stopped using those. Westermeyer make a Delta pressure sensor with 2 transducers that are synchronized. That works really well, and it has an automatic or manual reset on there. So even if it does reset and blow, and you're reading 0 psid on the transducer, the alarm is still on the actual sensor itself. So you reset it to push the button, it'll still show that it registered that. Now, here's the downside with these. If you have rapid load changes, especially on the temperate separators with the rubber O-ring, rapid load changes or on startup, you could blow that O-ring. You could have a 15 psid rapid startup pressure drop across that filter and blow that O-ring. I see it a lot, prematurely blow. So I do not like to use temperate filters in anything. I use the Westermeyer filters in everything. Westermeyer makes a filter to replace every single temperate filter. We started using them a year ago. We had way better separation rates with them, and they have a paper gasket at the bottom. The paper gasket does not blow out with those sudden load changes. So on Westermeyer's website, they list for each temperate separator, they list a Westermeyer part number for it. And they tend to be a little cheaper, and this way we're only carrying one brand of filters. So I like to use the Westermeyer ones a lot more.
We'll get
They
you
seem
guys
to
the
work
part
a lot
numbers on there.
better
We'll
also.
put that on the refrigeration, the Advanced Refrigerators podcast Facebook group, so you guys can actually see that.
Yeah. I mean, the other thing is when you are doing these filters, when you pull the lid off and you filter apart, every single time you get your flashlight out and look down there, I don't know how many times I've seen guys change the filter and they don't pay attention, and the O-ring's blown off, it's sitting on the base, or there's 2 or 3 O-rings on the base, and they stick the new filter right on top of them, and it's not going to seal because there's 3 O-rings at the bottom or 1 O-ring at the bottom.
Also be mindful on the temperate oil separator on the older style of the actual piece that sticks up actually threads on the nut to actually enclose that coalescing filter. The older style had almost like what looked like a birdhouse at the very bottom. Now the newer temperites do not have, but the filters that they have to replace this don't go well with the ones that have the birdhouse type bottom. I had a technician that called me up freaking out because he's trying to get this oil coalescent filter on this piece. He's like, I can't get it down. And when he tried to get it down, he broke it. It just completely broke off. This was because the newer temperate filters, they don't account for that older style. So they actually have a bulletin, actually have to make certain cut in a brand new separator coalescing element in the gasket or in the rubber gasket in order to make it actually fit. So just be mindful of that so you don't force it down, because that's what this guy did. He forced it down and then tried to tighten it down. And then what had happened was he ended up breaking it off. Well, at that point, the thing's probably 14 inches long and not that big in diameter. So there's no way that you're going to set a welder down there to actually fix it. So we had to change the separator. Thank goodness it was a scroll rack that had very constant flow. So it wasn't really shooting a lot of oil through. We just had to overcharge the oil separator because obviously at that point, if the element isn't in there, it's not separating any oil. It's comparable to having a impingement screen with a hole in it or a regular coalescing with a hole in it. It's not separating any oil at all. So.
All right. So I got to push because I had this happen to me. I had a guy work with me and he was changing the filter, and all I heard was, "Oh," and I went, "What does that mean?" He's holding the rod in his hand. I went, and of course it's Friday, so I went and got a piece, inch and an eighth copper. I measured it. I measured like the depth down to where the lid was. I made it slightly larger. I took the inch and an eighth copper and I put it down the center where the bolt hole was. Put the bolts on the separator. I went and got my M12 in fairing, sent it home on all of them. Torqued the living crap out of them, so that way it sealed on the copper as tight as it. That thing ran for 2 weeks
Let me get this straight. So you took
without
easy
any
to
issues.
right? Put it side. You had to drill a hole in it. Yes.
Yep. No, I put it up and down
Mhm.
on the
got-
top of the filter. So I put the
Gotcha.
filter in. I put the inch and an eighth copper. It was just slightly above the lip of the oil separator, just slightly enough where it put tension. It pushed down to the bottom to seal the temp or the filter on the
That's
bottom,
amazing.
and then sealed the hole on the top. And it ran like that for like 2
What the
weeks.
hell did you call it?
till
You
we got
call
the
it
separator.
bush sticks? Is that some kind of Chicago
Yeah, bush bit.
talk or what?
Maybe. I'm not from Chicago, so it's the Indiana. So I mean that's a fix there like that. You end up breaking rod. I know Westermeyer actually sells a repair kit for that. If you break one of their rods, you can actually get a repair
Wonderful.
kit for it, so you don't have to change the separator. So that's one option. So that's a brief overview of like how some basic tricks with the filter. You got anything to add?
Other than when like I
Brett?
was stating before, when checking for a high differential, preferably just shut down the rack for a little bit. Where then basically when all the if you elevate your suction pressure high enough, technically all your compressors should come on. That way you're checking the full capacity of that rack. So if you do have some sort of delta P gauge where it's actually intermittently going off and on, you might get there and you might only have 2 compressors running. The delta P gauge isn't going on, but then you find out by graphing, you're seeing that the capacity of the rack, once it hits 100, it actually is shooting a high differential, 13 PSI. So sometimes in order to find that high delta P pressure across the inlet and the outlet of the coalescing, you might in fact need to run all the compressors in order to actually find that from happening.
Great. So let's go over oil floats not filling. So this seems to be, or compressors not filling. So it's another big one. So you need to make sure you have, first and foremost, look at your compressor, see what your level is. What I generally do is if it's one compressor, it's usually related to that compressor. If it's multiple compressors low, then it's usually a system issue. Generally. So if it's one compressor, I'll start with that compressor. Make sure you have your net oil pressure from your reservoir or your feed line. Make sure it's to whatever it's supposed to be. If it's 20 pounds above suction, whatever it is, make sure it's at that. Make sure you have a full flow. Make sure your oil filter's good. And then you want to look at your oil flow. Feel the crank compressor. Is it smoking hot? Is it bleeding through? Is that why it's not pushing oil into the flow? Look at the float. I would inspect this. I'll see how the float is. I'll reset the float off the chart. See if it starts feeding oil. See if it's set off the chart properly. If it doesn't feed at that point, you need to check a couple more things to check your crankcase pressure. Not your suction pressure, your crankcase pressure. Because you could have an elevated crankcase pressure that could be greater than that oil feed line pressure. and it would not let oil feed into that compressor. So you need to actually see the crankcase pressure. If there's not a crankcase tap, what I will generally do, I'm going to pump the compressor down anyway, and I'm going to check my oil screen. So I'll pump it down. I'll add a tap at the same time with the crankcase, and then I will pull the screen on the float. Generally, it's a 3/8 screen on a flare. On the inlet, I'll pull the screen and check it. If the screen is clean, I'll start the compressor back up. I will check my crankcase pressure. If the crankcase pressure is acceptable, it's the same as the suction pressure, and you still won't feed oil into there, more likely the oil pot has failed or it is somebody had damaged it. If you find them all the way closed or open, generally like
So three helpful hints is checking to make sure you're not pressurizing your crankcase. There's a couple things that could cause this, right? You could have suction valves, right? You could have discharge flowing back into the crankcase and basically elevating your crankcase. So if you do a pump down test, that'll check to make sure that your suction valves are in. If you have the compressor off and the compressor's been off for quite a while, but the discharge line is still smoking hot, then that's telling you that your discharge valves are bad. In fact, shoving discharge back into your crankcase once again. One of the things that you can look for, if you ever have looked at an oil pod or an oil level control, at the top where there's no oil, where there's basically refrigerant vapor, it's fairly clear. If you look at it, it's clear. You can see the bulb right through the sight glass. Obviously, as long as the sight glass is clean. If you see misting, if there's like a fog, that's indicative 100% that you have some sort of discharge gas flowing into the crankcase. And you will see this. It'll look like it's misting. It's foggy right in the top. If you see that in your compressor and there's no equalization line between the compressor to other compressor, chances are you have some sort of blowback that's preventing that oil from actually going into the crankcase. It's elevating the crankcase pressure, making it higher than what the reservoir pressure is. Like we said, we have to have a difference in pressure in order to have flow, right? So if we have an elevated crankcase and we have an elevated reservoir, there's no flow. So look for that misting. That will help you out immensely with trying to figure out what it might not. Like I said, it might not be an actual oil float or oil pod issue. It might be that you have an issue with your actual compressor.
Yes, correct. I mean, it happens a lot. One thing to look at, just check the oil feed line. If it's smoking hot, generally you're getting some vapor through there. So if your oil feed line is just smoking hot, going into that oil float, you're getting vapor in there. You have you're either out of oil or you have another issue. So let's go over if it's too full. It's another thing. So generally you need to make sure that the oil float is set off the chart. And if it's not keeping the right amount of oil there, you also need to make sure it's not coming down the suction line. If you're not separating oil properly and you're getting too much down the suction line, you want to keep the oil at the right. So if it's not coming down there, I mean, I will generally pump the compressor out into the oil reservoir, and then I will turn it back on, turn the oil reservoir back on, and it fills back up immediately, right away. Then you know the oil flows. If you already reset it back to where it should be, and the oil pressure is not too high, whatever it should be, 20, 30 pounds above, and you have an oil flow failure. So you need to change the flow now. Generally, it seems like these Emerson oil floats, I don't know if you see a lot of them, Brett, they seem to fail a lot.
Well, that could be due to having, if you have a rack shutdown, basically that compressor fills up with liquid and then that rapidly expands when it goes to start back. It could potentially damage the flow. The Emerson ones, usually the part number on them, I believe, is an OLC. You'll either see an OLC2. What that means is that it is automatically set for an 1/8 inch of a blast. If you see an OLC-4, that is automatically filled for a 1/2 inch. If you see an OLC-2-4, then that means that's the adjustable one. That is, you can adjust from a 1/4 inch all the way up to a 1/2. See an OLC-2-4-N. That N represents that there is a equalizer line on the back of the actual oil pot.
Yeah, I mean, those
Yeah, there's no screen on the inlet on those.
oil or a filter and a meter.
Absolutely.
Yeah, so I mean that could be why they fail also.
Well, I don't think we finished talking about the OMB, basically how that, since we're talking about different ways to fill up the compressor. And we also didn't talk about the compressors that have the equalizer lines on them and the potential problems that you could have with that. If you want to cover the OMB, I'll cover the equalization.
Okay, so with the OMB, you're using a electronic oil float, and a couple things with this. So the OMB is 24 volts. The OMC is either 120 or 208, depending on which one you have. So basically what it's doing is it has a float inside the compressor in a ball. So it sees it raise up. It's going to say, once it sees it drop down, it's going to start to fill light. It'll attempt to fill so many times, and then it'll soft lock out. And after it soft locks out times, then it'll hard lock out, and then it'll close the alarm. Basically what it's doing is it's opening a ported solenoid valve inside of the oil float that is allowing oil to inject into the compressor. Now it's not full flow 1/4 inch. It has a drill port in it, so it's smaller. Same thing with an OMC. It's the exact same. Except it's using 120 or 208. Usually they either work or they don't. The issue comes in is when guys do not stick the rods in them in a scroll compressor. You do not need the rods in a recip compressor, only the brass extension rods. Those only go in a scroll compressor. And if you do not have them in there, they will cause nuisance, trips, whether it be high or low.
Technician actually coincidentally just called me, I think it was yesterday, Domingo. He called me up and he's like, I don't understand. This thing has no oil in it, but it's green. It's garbage. It's junk. Not working. Because the oil level was, although it was down, he had no oil in the compressor. Basically, the oil level needed to come up, but it was saying that it was green. The only thing I told him to do for the meantime is throw a magnet on where the solenoid coil is, just to get some oil into the compressor, so he can get the damn thing running until he can actually get the OMB back. You know.
Yep. I mean,
one more thing about the
Wanna go over the,
OMBs and the OMCs, there is in that where the 1/4 inch line actually hooks up, there is a filter screen in there. So be mindful if you do in fact have a oil filter that does have a bypass where it's actually able to bypass, you could potentially throw garbage into that screen, which could potentially cause your oil not to go in or to fill very, very slowly. So just be cautious of that. There is also a screen in there that, that is cleanable, is serviceable. It's nice because the solenoid technically should be locked down. You might have to, as long as the OMB is functioning properly, you would just basically have to close off your oil line in, and that solenoid should shut. So you wouldn't have to technically pump down that compressor in order to actually clean that screen, unlike your regular conventional regular mechanical oil pots or oil level controls on the side of the compressor. Those you definitely have to shut down, pump down the whole entire compressor in order to service them. Yeah, oil baths are bad.
Just be careful so you don't.
All right. We're also going to talk systems that have oil equalization lines. All right. You see these predominantly on Husman racks that are utilizing Copeland compressors. You'll also see them on some hill racks with Carlisle. The only thing when they're hooked up between the Carlisles, because Carlisles are very finicky with their oil level, you'll only see the oil equalization line be shared on the same suction, and you'll also see it shared on compressors of similar heights. So be mindful of that. If you see the oil equalization line hooked up to a big 6-cylinder and then hooked up to an itty bitty 4-cylinder that's like half its height, that's wrong. Someone screwed up. The compressors actually have to be the same heights in the Carlisles. Copeland compressors are basically all the same heights as far as where the oil level control goes. So it's not as imperative. That's why typically those compressors, as long as they're on the same suction, are all shared. The purpose of the oil equalization line is a great thing. The reason why they have it is you might only have one compressor running all the time under a low load situation. Well, if you do have some oil out in the system, the oil level control on the side is only going to fill it up when it's low. It's not going to be able to remove that oil if it's too hot. So the oil equalization line is there for in case that one compressor gets too high with oil, it can share the oil with the other compressors and expel some of that oil that I gotten back for a return. We had a certain customer that we just took over these stores. They had a Carlisle compressor and we had replaced the compressor twice, not realizing that the contractor before us had actually cut off and welded off the tap that would actually go to the oil equalization line for this one compressor. So basically this compressor was the primary, the one that had a lot of the unloaders on it. It would fill up with oil, and we would break rods and the thing would vibrate itself. That's once we broke the rods and broke the piston. And this had happened twice. And it wasn't until I went out there and saw that the oil level was the oil line was actually, the equalization line was supposed to go under the belly of this compressor there, because someone had actually removed it thinking they didn't need it. We ended up replacing it, and we haven't replaced that compressor since. So now you guys know what the reason is for it. So like I said, as long as one compressor fills up too hot, it'll be able to actually share that oil level with that spare oil with the rest of the compressor, so you don't overfill one of your compressors. Now the bad thing, you can cause one compressor that has piston valve issues actually cause oil failures on the rest of your rack, on the rest of your side. So once again, I'm going to go back to the pressures, right? I'm going to go over this again until I'm blue in the face. We're going to have discharge pressure on our oil separator on a low temp oil system, right? Or low pressure oil system. Then it's going to go down to an intermediate pressure. And then it's going to go down to the crankcase pressure. You need the pressure drops in order to have flow. Now, if we have one compressor, like we discussed, where it's actually blowing discharge gas into the crankcase, normally that would just affect that one compressor. Because the equalization line is actually connected to the lower end of the oil level control, what happens is any discharge pressure that actually builds up in that crankcase is going to end up sharing and going to the other crankcases. So instead of having one compressor having an elevated crankcase pressure, now you have three, which means now you have three compressors that are not going to want to take any of the oil and potentially cause an oil failure on all three. Typically when this happens, you arrive on site, you'll get a failure for oil failures, but you'll also get a failure for high suction, because basic compressors will probably be off of that because you had too high of a pressure in your discharge going into your crankcase that's elevated all the crankcases, not allowing flow. Once I get the oil in the compressors and I start running them again, I use the misting to try to figure out what compressor is my girl, the one that's actually causing the discharge pressure to blow into the crankcase, which is causing the oil level not to fill up on any of the compressors. looking for the misting. There's usually a shutoff valve for each equalization line on every single compressor. So if you see misting in all three, which you will, because basically that discharge gas is blowing into the crankcase of all the compressors. If you shut off one equalization line and the other two clear up, they're not misty anymore, then the one that you just shut off that was sharing, that's the one that ended up causing the discharge pressure to blow into all the rest of the compressors. So that's a very, very easy thing to look. You're basically just looking for misting. At that point, then you can do a pump down test and see what's actually wrong with that compressor to actually, unless something is drastically wrong. Discharge valves, suction valves, could also be you drop the piston or something like that inside the compressor.
Yeah, I generally like
Can't do it on a car lot.
valves off. I think they cause more problems than they solve, unless unless you have a low load situation. Unless you have a low load situation, they're like off. But I mean that I've heard 100 different guys say it 100 different ways. It just depends. I mean, like Copeland, if it's if it's got a digital on there, you probably need to have it on there, depending on how low the load is. If you got a high load rack and you're enabling the abandon on the compressors and you're keeping those compressors moving, and you're not going to have an issue. And in most circumstances, but if you have a compressor that is running all the time and with a bunch of unloaders, you're probably going to need the equal.
I think that covers everything with the equalization line. One of the other issues I want to cover is basically when you have a compressor that's sucking out so much oil, or what we refer to as a pumper. Basically one that's sucking out so much oil that it's actually draining out all the oil out of the line as well as the oil reservoir. Typically, I would say a compressor would typically, like a 4D Copeland, might pump out a whole compressor in, probably hour and a half, right? Does that sound right?
Yeah,
Uh,
maybe
I had
little
some,
faster.
actually 7 compressors on one rack that were pumping out in less than 5 minutes. I thought maybe that I just had a killer blockage on the oil filter, so I changed that because the oil looked dirty. Changed out the oil filter, changed out the Y1236, the oil regulating valve. And by the time that I shut down the oil and let off the pressure in the suction and started removing the oil filter, I had already had 3 compressors trip on oil fill. They had pumped out. I timed it. It was like 2.5, 3 minutes. Basically, I basically had in all my compressors, I had more the system that caused bearing wear in the on the main crank in the main journal. Basically caused the pistons to wear funny. I have some pictures where actually it looks like it's egg shaped at the top. If you take off if anyone's ever taken off the compressor, it's basically it's the color of steel, right? Unless it's black from excessive heat. This looks like it's red clay. That's what it looks like. And actually, Kevin, you saw pictures. How bad was this one? So that
was pretty bad.
my compressor pump out in like I said, less than 5 minutes. It had to be like 2.5 minutes. But if you have a compressor pumping out faster than hour, half an hour, 15 minutes, what's your cutoff? What's your cutoff before you're going to start really investigating and tearing that compressor cover?
Probably half hour. Scrolls, they seem to pump out a lot faster.
Yeah, there are some there are
15
some
minutes.
compressors. There was I think a plate or something that we had to actually put in front of the OMB control on a couple of the compressors, because I don't know if it was almost like that you were discussing.
Yeah, it's a plate that goes on there that blocks the hole and extends out the rod, because the compressor basically it's so volatile inside the crank or inside the motor housing, where because the
And it
motor's so
causes
low,
intermittent trips,
it
right?
actually looks like there's no oil in there, and there actually is oil. Yep, causes it to keep filling because it thinks there's no oil. So that plate has to be in there. But again, like I have never.
Do you have any
seen
more
one
oddball oil
compressors
failure
that's a
stories you
bad
want to
job.
tell that might be helpful?
It's the typical
Okay.
blow by or cycling issues. So rapid cycling issues causes huge oil problems, meaning load control. You poor load control, high compressor cycles, high compressor cycle. Every time you start that compressor, you're moving a ton more oil than you would normally when you operate. So high compressor cycles, you want to look out for compressors that are not operating properly, running high discharge temps, defrost scheduling that's too many at one time, overlapping hot gas defrosts, stuff like that. Like that rack needs to run smoothly. Low suction pressure set lower than design, not floating at all. That causes oil to not separate good, because now your mass flow is lower than it should be on a suction. So now you have less oil returning back to compressors, and you actually end up causing, less separation, less oil return. And then also another big thing is making sure your suction filters are clean and pulled. I prefer pulled. So making sure that you don't have any restrictions on those suction filters, because if you do, that's going to greatly reduce your oil return to compressors. So, but making sure that you have a smooth running rack when you have oil issues. I don't know how many times I've been behind guys and they're there for oil trips, and there's compressors that are not running 300 cycles a day. So by the time you get that taken care of, a lot of your oil issues will go away. And one other trick I want to go over is that if you have compressors that are filling with oil and they're not running, so say you have an oversized rack and that compressor hasn't run 12 hours and it's just filling up with oil. It's coming down the suction line. It's not coming from the oil flow, it's just coming down the suction line. So with Emerson, I don't know so much about Dan Foss, just learning a lot about Dan Foss, but you could program an abandoned. Same thing with microthermal, you could do the same thing. That basically tells that compressor, if it hasn't run whatever you program it, so say like 4 hours, it'll force that compressor on, if it hasn't run in 4 hours, to run for however long it feels like it, to get that oil moving and keep it from filling the compressor up. So that is a way to keep filling up compressors. You can use that abandoned on there. I like to go 4 to 6 hours, depending on what my load is, to try to circulate some
So
of that
for
oil in
every
those
4 to 6
compressors.
hours, you're saying
If I
the
have an
compressors that
oversized
you
rack,
deem to bend where they haven't ran for that long, basically you'll have them forced on. The controller will automatically force it on for 15, 20 minutes. Is that correct?
yep, it'll force it on, get some of that oil moving in there, compressor warmed up, keep it from liquid condensing in it if you don't have crankcase heaters, and it'll just get the oil out of it. That way
One
it's
of the
not
other
filling
things
up
I
with
didn't
oil. I've had
cover,
great success with
only
that.
because it came to light today, I will be putting up a picture on the Advanced Refrigeration Podcast page. For technician sent me a picture. He wasn't sure how this thing was split down. Right, they had a line coming from the OCV going into the section header for the medium temp, but also in parallel with it, they had a solenoid that was going to the low temp. If you do see that, typically how that setup is actually working is remember, we always want to be at the highest suction group when we have a dual temp, header, right? When we do dual pressure header, we want to be at the highest pressure. The way that one works with the solenoid, typically you will have an auxiliary set of contacts on your medium temp compressors. If none of the medium temp compressors are running, those sets of contacts will then be closed because you're going to wire them up to normally close. And then it's basically going to power up the solenoid. So instead of the OCV then going to the highest suction because the highest pressure compressors are, not running at that point in time, it'll actually open up that line to the low temp and then keep the low temp compressors running. Because usually the low temp header has more of a constant load than a medium temp.
Yeah, agreed. I mean, that's not
But you will
a
see it.
thing you see very often. That's one of those oddball things. So I think this is wrapping up the oil part number 2. We can have at least probably one more oil podcast where we go over some fine tuning stuff and maybe get a manufacturer on here to talk a little bit, go over some other things. But maybe we're gonna go over sizing on the next one. So
Thanks, guys. Have a good night.
that said, we're gonna wrap it up for tonight. Appreciate